Hello everyone, I'm Bhuvan from Sri Venkateshwara College of Engineering, Bengaluru, currently pursuing my 4th year of engineering in Information Science branch. Today, I'm here to present my technical seminar presentation on the topic of network intrusion detection system using machine learning, which will be deployed in a cloud infrastructure. This presentation was only possible under the guidance of Mr. Maria Naveen sir, who is an assistant professor in the Information Science branch. Contents of this particular presentation: we have introduction, related background, system architecture, working and implementation, future enhancements, conclusion, and references. Introduction. In today's digital era, network security has become a backbone of multiple industries and organizations. Cybersecurity threats are becoming increasingly advanced and more sophisticated. However, they are also vulnerable to various attacks and threats such as hacking and malware attacks, phishing, etc. A network intrusion detection system is a powerful tool for identifying and mitigating these kind of attacks and threats. By utilizing machine learning techniques, we will be deploying a NIDS solution in a cloud infrastructure, and this will help us enhance the system's performance and efficiency. The purpose of this particular presentation is to demonstrate how to deploy a network intrusion detection system using machine learning model, which will greatly enhance the network security. We will be discussing some key features and about system architecture, implementation of this solution in a cloud infrastructure, and some of the potential areas where we can enhance in the future. Before diving deep into the details, let us first go through some background research for the network intrusion detection system and network security in general. Related background research. Traditional network security measures are firewalls, antivirus solutions, etc. But these are very insufficient and inefficient in detecting these advanced threats. Hence, network intrusion detection system can identify these network attacks, and NIDS is a specialized type which monitors network traffic data and alerts the user for any intrusion. These traditional methods often rely on already existing signatures and also rules to detect already known threats, which can easily be evaded by any advanced attacker. We will be using machine learning algorithms, which will be used to analyze the network traffic data and to detect patterns which are associated with malicious activity, which will enable us to identify any new and unknown threats as well. Deploying this NIDS solution in a cloud infrastructure will provide us with great scalability, flexibility, and it will also be cost effective, hence making this whole system easier to manage and maintain. The system architecture. The NIDS architecture consists of mainly three components, which are the sensors and taps, data processing engine, machine learning models. The sensors or taps are placed at some strategic points in the network, which will be used to capture the network traffic data, and then we will be forwarding this to the data processing engine. The data processing engine will be responsible for all the pre-processing of the traffic data. It will be extracting the relevant features, and based on only certain parameters, we will be then passing this data to the machine learning model to identify any potential threats. In this presentation, we will be using various algorithms such as decision tree, support vector algorithm, random forest classifier, etc. Here is a few block diagrams for the system architecture. Here in the left side we have the raw data first, which we will be gathering all the data sets from, and after gathering we will be pre-processing the data. We will be removing any null values or any missing data values in the data set, and then we will be making use of this data set to train the machine learning model using already existing algorithms. Later on, we will be deploying this solution in the cloud infrastructure by making use of the VMs available in some platforms and also the storage aspects. Later on, once we have deployed this as a cloud service, we will be making use of the APIs which will be present, and the whole solution will be created and linked with the cloud. At the right side of the presentation, here we have a complete network system where two campus wings are connected to each other. So we have the wing A and wing B, which is then connected to a firewall which has the internet and other campuses storage databases connected. So in this whole network, we have our intrusion detection system connected between the firewall and the network itself. Here we will be analyzing the network traffic data in real time. So any malicious activity or any already existing patterns, if are found, we will be alerting the user and will be taking respective actions. Some of the steps which are required to train a machine learning models are as follows. First, we will be gathering the data sets for training the machine learning model. Later on, in the stage 1, we will be pre-processing the data. As we discussed, we will be removing any null values, and also if we have some missing data in a certain rows, so we will be removing all that values. Then once we have done that, we will be parsing that data into a new data set, and then we will be choosing only certain features which will be relevant to our use case. Then with the existing data set, we will be splitting that into training data set and also testing data set. Usually we have 80% as the training data set and 20% for testing. Later on, we are next moving into the stage 2, where we are building our machine learning model and having the classifier ready. Here in this presentation, we will be training the models with respect to multiple algorithms to check which is the best algorithm, and then we will be tuning that particular model based on a few parameters to enhance the performance of the model. In the stage 3, we will be analyzing the results which are obtained by this machine learning model. So we will be comparing the expected output and the actual output which we have received, and we will definitely have documentation and any future recommendations we will be giving to the model at this stage. This is a sample data set for the network intrusion detection system. Today we will be using NSL-KDD intrusion detection system dataset. So we have various features and columns as shown in the presentation. So by keeping these features in mind, we will be training our data set and the machine learning model itself. Talking about the parameter optimization, so once we have our machine learning model trained and the best accuracy is obtained, later on we will be selecting a few set of features, as I said, and then based on the number of features which are selected, the precision or the accuracy score will increase, as shown in the graph below. This is essentially done to enhance the performance of an existing machine learning model. The NIDS solution which I'll be using today obtained an accuracy of 99% with the random forest classifier algorithm, which is demonstrating great effectiveness and efficiency in detecting any potential threats. Coming to the machine learning model training, here I have a Jupyter notebook where I'll be explaining how this particular model is trained. So first I'm just importing various libraries which we'll be using in this training of this machine learning model, and we have various algorithms as well which I'm just importing. And once we have done that, here I'm importing the training data set which we will be using, and I'm just printing out the dataset values just to verify if it is imported or not. We can also look into various statistics such as the number of records, what are the type of protocols which we are using, and various other data. Once we have done this, we are just removing any missing values or any null values which might be present in the data set. Essentially, we are optimizing the training data set to have it like pre-processed. Here we can see there are various features such as duration, source byte, destination bytes, if the user is logged in or not, and various other aspects. And today we will be training the ML model for these classes, which are normal traffic, DOS, which is denial of service, probing attacks, user to root, and also remote to local attacks. And these attacks are unique and are also very common in the cybersecurity space, and having our machine learning models be able to detect these particular attacks will be greatly beneficial for us. Now we are just printing out the dataset values, and later we will be splitting this particular dataset into training and testing dataset. So normally we have 20% for the testing dataset, and the rest 80% will be used for training dataset. And now coming to the model building, we are using various algorithms like logistic regression, decision tree classifiers, random forests, support vector machines, k nearest neighbor, naive Bayes, etc. And this is a short script where we are training the dataset itself, training the machine learning model, and with the help of the splitted training dataset, we are just calling the existing algorithms which we imported in the above code, and we are informing the user if the model is training, and once the model training is done, we are just informing the user that it is completed. And all these models, after they are trained, are put into a models list. Later we will be enumerating through all these models, and we will be essentially getting the metrics of the precision, accuracy, recall rates, etc. as shown here. So for all the machine learning algorithms, we have the accuracy for the training dataset, for the testing dataset, we have the precision, recall rate, and also the F1 score. So after going through all these algorithms, we can see that the decision tree classifier and the random forest classifier have similar training accuracy. But when we are considering with respect to the precision and recall rates, we can definitely see that the random forest classifier has a slightly better accuracy and precision. So we will be going ahead with the random forest model itself, and later we are tuning the model based on a few parameters, which are the n estimator and the max depths. So based on various parameters, we can also train and optimize this particular model. But here for only certain set of n estimators and max depths, we are testing our model and trying to essentially tune and optimize the model for greater performance. And once we have found out the best estimator where the model is working at its best and providing the accuracy, so we are just considering that, and I'm just printing out those values here. Later we are just now looking into the final metrics for this particular random forest classifier, which is 0.99, which is around 99%, and I'm sure that that is a very good accuracy, and this will allow the model to be very efficient and effective for any advanced threats like DOS or probing attacks, etc. So now we will be using this particular ML model, and we will be trying to deploy in a cloud infrastructure. And I have built a Flask application which is using this particular ML model, and this implementation offers various benefits like increased scalability, flexibility, easier to manage and maintain when we are deploying it in a cloud environment. And by deploying this in NIDS system, it is possible to scale up and down based on the traffic which we are obtaining in the system itself. So this will really help us in the cost perspective, essentially making the whole system both secure and also cost effective, which was not possible with the traditional on-premises deployments. So now coming to the working and implementation, we will be just going through the Flask application, which is deployed locally as of now. So this is the deployed Flask application, where I'm using the machine learning model which we just trained, the random forest classifier algorithm. Here, first we can select the type of attack. First we will be going with the DOS or denial of service attack, where we are just entering different parameters which we will be similar to a DOS attack in the real world. And once we submit, we can see that the expected outcome is DOS and the attack was detected, and the model also detected the attack as 100%, so that is very accurate. And later on we can go with the probing attack. We can just give some duration. The service protocol type, source bytes, destination bytes, the flag will be automatically set as all these values are coded into the Flask application itself. As we can see, the ML model again detected the probing attack. So next we can go with the normal traffic itself. So this is the normal HTTP traffic data which we are just passing, and as we can see that the normal traffic is detected, so the expected outcome is also normal. Like so, we can have the APIs available in the cloud infrastructure, and once we have a solution ready which is deployed in a network, we can just make use of these APIs and provide the required results in real time. Talking about the future enhancements which we can make, so some of the potential areas which we can concentrate on is improving the system ability to detect any zero-day attacks, which are really highly vulnerable attacks and can take down an entire system itself. So the ability to detect these types of attacks will be really beneficial, and enhancing the system to identify and respond to these particular network behavior, and by incorporating the advanced machine learning models, the system can be greatly beneficial to a lot of industries. We can also integrate this network intrusion detection system to various other security tools, such as firewalls and other intrusion prevention systems. Hence, we are creating a more comprehensive solution for network security, essentially. Coming to the conclusion, this presentation mainly discussed on how to train the machine learning models and the implementation of this network intrusion detection system, which uses machine learning algorithms and can also easily be deployed in a cloud infrastructure. The system achieved a high accuracy rate and also gave a low false positive rate also. So essentially it is demonstrating its effectiveness in detecting any potential threats which might arise. The research is a significant progress because it addresses the much needed research and work to be done in more advanced network security measures which should be taken in this digital era, and also demonstrates the potential of machine learning and cloud computing technologies, which can greatly help us in enhancing the network security. This research has wide implications for various industries and organizations that rely on network security and reliable infrastructures, such as financial institutions, healthcare providers, and other government agencies, where the security of the user's data is very essential, and the system architectures should be very reliable also. These are some of the links which I have referenced to. So there are various IEEE publications which I referenced, and I have also included some of the links where we have a detailed tutorial for how to deploy the Flask application, and what is machine learning basically when it comes to network intrusion detection systems, etc. Thank you for watching this video. I hope my technical seminar presentation was helpful.